Good morning. This is me going over the Khan Academy for volume. I'm going to start with the first one. I don't think I'll do all 4 problems for each, but I'll do a couple of each. So we're going to start with the volume cross sections that are squares and rectangles. Okay, so I've got my Khan Academy up. Do the same thing as yesterday. Get yours going, and we'll go through the first few. So here's the first one that comes up for me. Again, oh my gosh, if it's not the first one that comes up for you, that'd be really bad. But it should be. I think I've got it down. So we've got, the little intro to this in case you feel very confused. Volume with cross sections, the whole idea is you're going to be given some enclosed area. So maybe you have a parabola and maybe you have a line that's horizontal. And they say this area here is the base of a solid. The cross sections perpendicular to the x-axis for this solid are squares. Find the volume of the solid. So what that means is perpendicular to the x-axis, you have the base of a square coming this way, coming up off of the desk, over and back down to the desk. I'm drawing it slanted to kind of get a view of what it would look like. But you go back and watch my other videos on it to get an idea of what the heck it is. But we're basically building our own volume now. We're not rotating, so we don't automatically get circles. We're building it ourselves out of whatever shape they tell me to use. So they're giving me the base, and then I'm building a volume out of that base with whatever cross-section they tell me to use. So I'm going to always be integrating the area of one of these cross-sections, because last time it was different. I had a space that rotated. So the cross-sections were automatically circles, sometimes with a hole in them. Automatically, I built these in a different way out of a revolution. So I had these circles with a hole in them. Now I don't. Here's the base, and I'm building them by stacking all these rectangles or squares. So in the old way with washers and stuff, I was still integrating the area of a cross-section. We just didn't really talk about it like that, but I was still integrating the area of one of these circles or the area of one of these washers from left to right. I was still stacking up all of these things. Now I'm stacking up all of these things as well, but they're not always circles that got built from a rotation. Now they're squares or triangles or rectangles or whatever. So, first one says the base of a solid is the region enclosed by the graph. So I'm still going to do a little sketch. Y equals the sine of x, y equals 4 minus root x, and between x equals 2 and x equals 7. Ooh, that's fun. I don't know if you'd get a calculator or not. You just heard my little drawer open of my calculator. Let's just see if this is like intuitive or not. So y equals sine x would look like this, at least one hump of it. Let me get 2. But I'm only going between x equals 2 and x equals 7. So this is 2 pi, this is pi. Huh. Okay, this is gonna be weird. And y equals 4 minus root x. So 4 minus root x, of course we start with a pretty difficult one. 4 minus root x means go up 4. The square root of x goes like this, but it's the negative square root of x. We're gonna be coming down. I'm just not sure how far down without plugging in a couple of numbers. Let's see, if I plug in 4, get 4 minus 2, I'd get 2. And I'm going to come down something like this. And they want me to find, this is the base of the solid. Cross sections of the solid perpendicular to the x-axis are rectangles whose height is 2x. So from x equals 2, which is maybe about here, to x equals 7, which is 2 pi is 6 point something, right? So which is about here, I have this space. And my rectangles are going to have a height of 2x and a base of whatever this is. I'm going to get that on my calculator because I want to see what it looks like. Let's see. You hear my cat? He drives me up the wall. He's already been out like and in about 27 times today. Make sure you're in radians. Oh, there we go. Okay, that makes more sense. My picture was a little bit off. Okay, that makes much more sense. It's going to stay above the whole time. I started thinking, well, when I'm going to get the base of one of these rectangles, I want to just do top curve minus bottom, but I thought that was going to change, so I thought we might have a problem. We don't. We just have a problem in the way I drew it. So here's the sine of x, and here is, this is only 1, right? The sine only goes up to 1, so 2, 3, 4, whatever. We're going to fudge it up here, and that's going to stay above the whole time. Okay, so from x equals 2 to x equals 7, we have this space. There we go, that makes a lot more sense. So we don't need any of this. This is 2, this is 7. So the base of the solid is this, and the cross sections perpendicular to the x-axis are rectangles. So we have the base of the rectangles here and the heights coming out at me. They told me that the height of the rectangle is going to be 2x. The base is this. So how do we measure that space? We just do top curve minus bottom, just like if we were getting the area. Top curve minus bottom. So the top curve is 4 minus root x. The bottom curve is sine x. So there's my rectangle. I want to integrate from 2 to 7, the area of one of these rectangles. So 2x times 4 minus root x minus sine x with respect to x. So there is my work. Looks like they I don't know what the heck they did. Let's distribute this. So I have 8x minus 2x root x minus 2x sine x. Oh, never mind. Okay, I just didn't scroll down far enough. The answer is, why do they have it that way? Oh, they don't. It's A. Oh my gosh. Why did that take me so long for my eyes to find? They just had these flip-flopped. Sorry, it's A. Whew. Such a pretty sound. Okay, so let's see. So we definitely want to do number 2 together as well, because we're going to have our things be perpendicular to the y-axis, which is a little bit different. Yesterday I was filming a video for you guys and my phone cut out. It said it didn't have enough storage. I had to go back and erase all kinds of stuff. I was not a happy camper. Okay, so this time they draw a picture for us. This is up at 0, 3. This is at root 3, 0. It's just this space in here. This is y equals 3 minus x squared. Okay, region R is the base of a solid whose cross sections perpendicular to the y-axis are squares. I don't know that we've done one of these together. So now instead of my squares going this way and up at me, the squares are going this way and up at me and down. Oh my gosh, my dog is seriously taking a poop right outside the window. You don't need to see it, but I just, like, oh, literally right out there. Atticus, that's so inappropriate. Oh my gosh. Oh, it's good stuff. Sorry, it's funny. Sorry, inappropriate. Okay, so the squares are perpendicular to the y-axis. So they're there and they're coming up out at me like this. So when I'm oriented that way, a couple of things need to change. One of the things that needs to change is easy, and that is when I integrate, I'm not going to be stacking these squares from left to right. So I'm not going to go left to right. I'm stacking them this way. My squares are all stacked this way. So they're being stacked from bottom to top. So my bottom y to my top y is what I'm going to be integrating from, and therefore everything's going to be in terms of y. That's the difference. When I'm this way, I'm stacking the squares this way, so from bottom to top. If they were perpendicular to the x-axis, I'd be stacking them from left to right. Now I'm stacking them from bottom to top. So this needs to be changed in terms of y or whatever. So I need to solve this for x. So I'm going to have x squared equals 3 minus y, and x is going to be the square root of 3 minus y. Now, how come I don't need a plus or minus? If I had a plus or minus, that would give me both sides of this parabola. The plus is going to give me this side, the minus would give me this side. So I only need the plus because I only need the right side. So there's x. So one of these squares, what are the dimensions of it? Well, the dimensions of the one side and the other are the same. So to find the length of this side, I'm just right curve minus left curve. So 3 minus y square rooted minus 0. So the square root of 3 minus y is the side of both side lengths of the square. So the area of the square is root 3 minus y times itself. So in terms of picking an answer, the square root and squared undo each other, and I just have 3 minus y, so it should be A. Beautiful. Okay, the next one I'm going to have you try yourself, and I'm just picking a random guess, and the last, whoops, shoot, sorry. Just want to look at the fourth one and see what it's like. Unfortunately, I can't see these ahead of time. Okay, that should be okay too. So now I'm going to go into the other one where the cross sections are semicircles and triangles. So don't skip the last two, go try them. All right, Sorry, I showed you my dog pooping. Okay, so now we've got the cross sections with triangles and semicircles. So the first one, oh, we have E, love that. Y equals e to the negative x, and we're going up until here where x is 1. Cross sections perpendicular to the x-axis are equilateral triangles. Okay, so I have cross sections are perpendicular to the x-axis, and they're equilateral triangles. So they're going this way, coming up at me and back down, at me, back down, at me, back down. So I know that I'm going to be integrating from left to right, so that's good. Left x to right x. And I need to figure out what the area of one of these triangles is. So I have an equilateral triangle. All the sides are the same. The base of that triangle is all that I know right now. The base of the triangle is the height of the curve. So the base of the triangle is e to the negative x. All right, that's how big the base of the triangle is. Well, I need 1/2 base times height, so I need to figure out what the height is. Well, this triangle is a 60, 60, 60 triangle, so this little one is 60, 90, and 30. So how do we figure this out? I'm just going to give myself more room. If the entire base was e to the negative x, this much is 1/2 e to the negative x. And the rules are, if this is the 30-degree side and I need to find the 60-degree side, the 60-degree side is the 30-degree side times root 3. So this side's going to be root 3 over 2 e to the negative x. So the area of my triangle is going to be 1/2 times the base, the entire base, times the height, root 3 over 2 e to the negative x. There's my integral. They want the exact volume of the solid, so let's see if this should be fairly easy to do by hand. Let's take out the constant. And what's e to the negative x times e to the negative x? This is good to do by hand because it reminds you of some of these little rules that we don't ever go over them like by themselves, but it's really good, or you do have to know these rules. So like what's e to the negative x times e to the negative x? Same base, add the exponents, So negative x plus negative x is negative 2x. That's just one of those little things that you definitely need to know, but does that mean we all know it all the time? Sometimes not. So getting reminded of it in little ways is a good thing. Okay, so let's integrate this. So root 3 over 4. The integral of this is e to the negative 2x divided by negative 2. And we are integrating from 0 to 1. So I'm going to have negative root 3 over 8 times e to the negative 2 minus e to the 0. Right, plug in, I grouped up, watch this in slow motion if you have to. I grouped up all this. I'm going to pull that out for now and deal with it later. And I'm plugging in 1, plugging in 0. So what do I actually get out of that? Negative root 3 over 8 times 1 over e minus 1. They want the exact volume of S, which means they do not want you to get the decimal and round. They want you to get the exact value. So this is one way to write it. I guess they would take it that way. Just in case, I'm going to distribute my negative root 3 over 8. So I'm going to have negative root 3 over 8e squared. Whoops, I missed a squared. That came down as a squared. Plus root 3 over 8. Let's see what happens. I don't know about this. I don't have a very good feeling. What a surprise. Negative root 3. Oops. Negative root 3 over 8 e squared plus root 3 over 8. Oh, boom! That's how you do a problem at 7 o'clock in the morning. Sorry, that was rude. Go back and watch that again if you need to. Okie dokie, I'll do the second one as well. Oh my gosh, don't get animals, they're so annoying. It's 7 o'clock in the morning, my cat's out there making noise, my dog's making noise, he's pooping on film. Like, what is happening in my life? How did I get here? My kids are watching Ninjago in the other room. My goodness gracious. Okay. X squared plus y squared equals 16. Beautiful equation of a circle. Cross sections perpendicular to the x-axis are isosceles right triangles with the hypotenuse lying in the base. Are they trying to kill us, man? Cross sections perpendicular to the x-axis, okay, this way, are right triangles with the hypotenuse lying in the base. So they're coming out at me like this. Here's the right angle up here. Isosceles, these two sides are equal with the hypotenuse lying in the base. You jerks, what a terrible. Why would they do this to us? Isosceles right triangle. This is lying in the XY, or blah, 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 perpendicular to the x-axis. Terrible. So these are all coming up at me with right angles. If these are right angles, it means these are 45, 45, 90 triangles. Ooh, I'm going to need to know those rules. Okay, so first of all, how do we figure out what the length of this is? Well, I need to do top curve minus bottom curve in a way. I can't just like go and give this. That's going to not work. So let me solve this for y. That's going to help give us the top and the bottom. So y is going to equal 16 minus x squared, square rooted. That means the top of this circle is the square root of 16 minus x squared, and the bottom of this circle is negative square root of 16 minus x squared. That's how that plus minus thingy works. The plus is the top part, the minus is the bottom part. Oh my love of God. Pause, hold on 1 second. Can somebody please go let the dog in? And now they will fight about letting the dog in. I love it. Okay, so how do we figure out how to label this? Well, if you just stay in the way we've always done it, this side can be top curve minus bottom curve. The top curve is the square root of 16 minus x squared. The bottom curve is negative square root of 16 minus x squared. That's how I can label this entire side, top curve minus bottom, which I can also think of as just, because this changes to addition, 2 root 16 minus x squared. Oh my, there we go. That is how I would label this entire side. All right, I'm going to erase this because I don't want all this written here. It's too much. But this side is this. Okay, so I still need to integrate the area of the triangle. So I need to take the integral from left to right, which I'll say in 1 second, of 1/2 base times height, of which I have neither at the moment. All I have is the hypotenuse. So to get the base, what do we do with 45, 45, 90 triangles? The rule is 45, 45, x, x, root 2x. 45, 45, 90 rules. Again, something you do have to know, and we forget sometimes because we don't have to use it a lot. So if I have the hypotenuse, how do I go back? I divide by root 2. So this side is going to be 2 root 16 minus x squared divided by root 2. And that's what this side's going to be also. Okay, both of those sides are equal, so they're both going to be the same thing. So the base and the height are the same thing. So the base and height are both 2 root 16 minus x squared over root 2. I know I could just write squared, but I'm writing it out just because maybe it's easier for people to see. So here's my integral, 1/2 base times height. From what to what? Well, I got to go from left to right. Well, what is the left side? What's the right side? Well, this is a circle. This was the original equation of it. So the radius is 4. So here's -4, here's +4. So we're going to go from -4 to 4. Determine the exact volume of the solid. Oh, they want you to do this out, so they don't even want you to use a calculator. Let's see what happens. So let's put this together. Let's make it nicer. All right. Can we say this 2 and this 2 will cancel? Root 2 times root 2 is going to be 2, which will cancel with the 2 up here. So that'll all be gone. Root 16 minus x squared times itself will just be 16 minus x squared. Well, that's a lot easier than I thought. So I have to integrate this. I'm going to go up to the top to integrate this. So I'm going to have 16x minus x to the third over 3 from -4 to 4. Let's get that. 16 times 4, is it 94? It's a really stupid question. Wait, what? Oh my God. 64. Wow, I don't even know where my brain just went. Okay, 64 minus plug in 4. 4 to the third is 64 thirds. Plug in -4. This looks a lot like what I did yesterday. So 64 plus 64 is 128. That so minus 128 thirds. Can I just put it in like that? Determine the exact value. Shouldn't have to. It says your answer should be a simplified proper fraction, a simplified improper, or a simplified improper fraction. You jerks! So they are making me get a common denominator. So I need a 3. I'll probably make a mistake like I did yesterday. (256 over 3). Let's see. Yay! Oh, that's such a good sound. Okay. All right, the next one is another isosceles right triangle. Have fun with that. Oh my gosh, I just got the right answer by guessing. Totally no skill whatsoever. And the next one's equilateral triangle as well. Okay, it didn't give me any semicircles. So, I don't know. We'll try to make sure we see when we do more practice. That's it. Enjoy. I really hope that you are feeling more confident and you enjoyed today's lesson.